Hey everyone. Today, we are going to talk about an important element of lean manufacturing, OEE, overall equipment effectiveness, which is a crucial measurement in the improvement approach called total productive maintenance, TPM. Before you begin learning about OEE, it is useful to understand a little bit more about TPM. TPM is a company-wide approach for improving the effectiveness and longevity of machines. It is key to improve the capability of equipment since it attacks major wastes in production operations. The main strategies used in TPM are often referred to as pillars that support the smooth operation of the plant. Overall equipment effectiveness is important and relevant to all TPM pillars, but is probably most important to the first four pillars. This is because these pillars can directly influence OEE through daily operations, maintenance, or improvement activities. As we know, adding value to materials is what manufacturing companies want to satisfy customers and make money. Therefore, the more effective the process of adding value would be, the more money the companies could make in a certain time. Overall equipment effectiveness, as a measurement used in TPM to indicate how effectively machines are running. Moreover, it includes more than the quantity of parts it can produce in a certain period of time. When we measure overall equipment effectiveness, we account for efficiency as one factor, including availability, a comparison of the potential operating time and the time in which the machine is actually making products. Fi lowers and setup time are seen as downtime losses, which link to availability. Availability reduced by equipment failures is a common occurrence in many plants. Many of the causes of machine failure give warning signs before the machine actually breaks. It is also reduced by the time it takes to set up the machine for a different product. Performance, a comparison of the actual output with what the machine should be producing at the same time. Minor stoppages and reduced operating speed go to the element of performance as speed losses. Machines often run at speeds slower than they were designed to run to maintain stable quality that can't be achieved at the design speed. Minor stoppages are events that interrupt the production flow without actually making the machine fail. Quality, a comparison of the number of products made and the number of products that meet the customer's specifications. Scrap, rework, and startup loss are the defect losses that belong to quality. Scrap that can't be reused is a waste of materials. Even when products can be reworked, the effort spent to process them twice is a waste. Many machines take time to reach the right operating conditions at startup. In the meantime, they may turn out defective products while operators test for stable output. When you multiply performance, availability, and quality, you get the overall equipment effectiveness, which is expressed as a percentage. E gives a complete picture of the machine's health, not just how fast it can make parts, but how much the potential output was limited due to lost availability or poor quality. A waterfall chart is a good tool to visualize the equipment performance by illustrating what losses occurred during the operation in terms of the three elements in OEE calculation. I will also attach an Excel template for your reference to calculate the overall equipment effectiveness and present it with a waterfall chart automatically in a spreadsheet. The process of measuring and applying E data should involve the people who use the machines who are more familiar than others with the equipment they operate. With the involvement of workers and support from the top management, the collected E data will be used to drive improvement effectively. Here I recommend 5 aspects that you are better to take into account when applying TPM in your business. Monitor and use OEE. I also attached a template for collecting E data with an Excel file. Please check the description down below. Other than that, equipment history involves daily checking results, breakdown reports, work orders, and performance tracking, which could be supplemental data sources to help you understand the baseline of the machine performance level. Rely on autonomous maintenance. Workers lead and own autonomous maintenance. Workers typically know their equipment better than anyone. They will respect a maintenance plan that they have devised. That is the reason why we have to involve the frontline operators in applying autonomous maintenance, which encompasses cleaning and checking, creating standards, improving visibility, tagging machines, and monitoring equipment health. Streamline a repair process. The repair process can be streamlined by removing waste from the repair process and controlling the inventory of tools and spare parts. Deploy a preventive maintenance plan to prioritize planned maintenance and preserve specialist skills for complex tasks. Build capabilities through technical training of workers, teamwork, and problem-solving training. Deploy a preventive maintenance plan to prioritize planned maintenance and preserve specialist skills for complex tasks. Build capabilities through technical training of workers, teamwork, and problem-solving training. After watching this video, you may have understood the framework of TPM and the key elements you should adopt for implementing TPM and OEE. We will be discussing the quick changeover and other sub-KPIs that are relevant to TPM in more detail in upcoming videos. See you soon.